Hey guys, this is Divyashree, TSF GRIP intern, powered by the Sparks Foundation, and I'm doing data science and business analytics for June 2023 batch. Let's get into the first task. We have to predict the percentage of a student based on the number of study hours. Like we have to predict the percentage on how many hours they are studying. So we have to use simple linear regression in this, and I'm using Python language, and the data set is found by using this link. This is a link to find the data set, and this is a data set. Yeah, these are two columns here. We have to predict what is the relationship between hours and scores in this. So let's get into the code. Yeah. First of all, we have to import the important libraries like pandas for data manipulation and analysis, numpy for mathematical operations, matplotlib for data visualization, and matplotlib inline, which is used to display plots in Jupyter Notebook. Actually, yeah. Now we are reading the data from a CSV file, and we are naming it as data. So I wanna know the uh, shape of the data. I'm doing EDA here basically. So there are 25 rows and 2 columns. Now I'm using data.head to show the first data. So there are only 25 rows here. So I am um, displaying all the 25 data here. So this is the data of 25 scores and has. I am finding whether the data is null. So the data is not null. So everything is a false here, and I'm finding the information of the data. In this, we'll know about the data frame, the data types, and the non-null counts. Then I wanna know the statistical summary of the data frame. So I'm using this data.describe. So, in this we'll know the statistical summary such as count, mean, standard deviation, minimum, 25%, 50%, 75%, and maximum. And now here uh, I want to know whether the data is null or having missing data, and if there is any missing data, or if there is no missing data, I wanna need the sum of the data which is missing, which is null. So as we see here, there is no null values, so we'll get like the sum of the null values is obviously 0 for both scores and has. Now I'm finding the data.correlation, which calculates the correlation between the columns and the covariance also. Now I'm importing Seaborn. So Seaborn is actually used for advanced data visualization. So by using Seaborn, I'm displaying the I am displaying the heat map here by using the correlation, and this is the heat map. I'm knowing the value counts of hours, and also the value counts of scores. So the value counts actually counts the number of occurrence of each unique value in the column. So in house, like students who studied like for 2 hours is only 2 people, 2.7 is 2 people. Likewise, the hours for 7.8 hours, only 1 people has studied. Like that, the unique values in the column has been displayed here. Same for goes for this scores also is the same. Like for 30 marks, 3 people only got the 30 marks. Like 86 one people got, 42 one people got, like unique values of the column. Now I wanna know the sum of the scores. So individual score. So I calculated this. I got 25, and same for the house also. I got 25, and I'm finding the mean for the value counts of hours, and also for the value counts of scores. Now here, let's get into the data visualization part. Here I'm creating a pie chart with the house that value comes. Here the figure size is like 10,8. Now for individual values in the house, I'm creating this pie chart, and these are the values of the house, like we saw here. Sorry, here 2.5. These are the values that is displaying here, and showing the percentage of how many people has studied that many hours. Here two, and these people are all one, so it is displayed here. Same goes to scores here. These are the values of scores that students scored, and number of students scored the values here, shown here. And here I'm plotting the bar chart for the scores. I'm taking like top 150 value counts in the scores column, and this is the plot here. Is the same for the hours also. I'm plotting the bar chart, the figure size of 10,8. These are the values of hours, and these are the people studied, I mean students studied. So here I'm plotting the scatter plot for house versus scores. I am using a style of this. So I label x plot, x has hours studied and y has scores secured, and this is the plot. And yeah, let's get into the data preparation. So obviously I'm using linear regression here. So I'm taking x as these values and y as these values. Now from sklearn.model selection, I'm importing this train test split, which is used for training and splitting the data. Now I have taken the test size as 20% and the train size as 80%. So by taking that, let's get into the linear regression modeling. So I'm creating the instance of linear regression model here, and also fitting the model using the train data. Yeah, here I'm plotting the scatter plot for x and y values. I'm knowing the shape of the like x train, x test, y train and y test. Here are the values. Like for x train, I'm having 20 rows and 1 column. For x test, 5 rows and 1 column. For y train, only 20 rows. For y test, only 5 rows. And I'm also displaying the x test here, values of x test. And yeah, let's get into the model evaluation here. So here this predict val is like it predicts the target variable using the train model and the test features. So I'm giving these x test here, and I'm displaying the values of predval. Now here I'm plotting the scatter plot for y-test and predval. Y-test and predval. So I'm getting this scatter plot. Yeah, let's go into the model evaluation. Like now we are calculating mean square error. It calculates the root mean square error, also known as RMSE, between the actual and predicted values. So this will be imported from sklearn dot metrics. Yeah, here uh, we are calculating mean absolute value, which calculates the mean absolute value error MAE between the actual test and the predicted value. And now we are determining the model's performance here by R square. So we are importing the R square from sklearn dot metrics. Then we are calculating the coefficient of determination or R square to evaluate this model performance. Yeah, uh, I got like 94.54%. So yeah, I feel like this is good, and thank you.